Let's talk about complex numbers. So the imaginary number I, which is like a script I, is defined to be the square root of -1. Now there's not a real number that times itself is going to give me -1, which is why we call it an imaginary number, and we give it its own notation. If I is defined as the square root of -1, that means that I squared, when I multiply by itself, will give me -1. And there's a whole host of stuff we can do. We can look at the properties of the imaginary numbers and see that it cycles in groups of 4 and all that stuff, but we're going to skip that. We're going to focus on what parts we really need to know about for imaginary numbers. So a complex number then is a number that has two parts. It's got a real part and an imaginary part. So we generalize it by saying a plus bi. The a and the b are normal real numbers, any kind of real number, but the a is only a real number and the b is with the I, so it's the imaginary part. So if something asks for a plus bi form, that's what they're saying. Put it in form that tells me what is the real number associated and what's the imaginary number associated. The primary way we are going to be using imaginary and complex numbers in our class is in dealing with the definition, basically, and that is simplifying the square roots of negative numbers. So if I have the square root of -7, I recognize that's a -1 times a 7, so I simplify it as I times the square root of 7. If I know what the square root is, in this case 16 is square root of 4, I'm going to go ahead and I'm going to get just a normal 4i. So if I have radical notation, normally I will put the I in front of the square root just so there's no confusion. It doesn't look like it's actually underneath. It's just safer to put it there. If I have a normal number, I'll put the I at the end like I do with X's. This last one here, just want to show you, if you have the negative of a square root of -13, you're not allowed to multiply those negatives, so it is going to be a negative, whatever the answer is, in this case, -I√13. All right, so we are going to be doing some operations with imaginary numbers, and the first easiest ones we're going to work with is adding and subtracting. The good news, it's nothing harder than anything you've really done in math before, and that is combining like terms. So you put the imaginary parts together and you put the real parts together, boom, you're done. Don't let these parentheses throw you, okay? So if you have parentheses something plus parentheses something, there's a plus there. That means you actually are adding. So don't automatically think FOIL because you see parentheses. In this case, where it's adding is very straightforward. Where it's a little trickier is when I'm subtracting, because then I have to remember that I'm taking the opposite of everything inside that second parenthesis. So I have to change the sign for minus the 6, 5 minus the minus, or 5 plus the 3i. Multiplication is not much harder. There are a couple notes I have to keep in mind. The first is before I do anything with square roots of negatives, I have to put it in terms of I first. The second thing is I always have to make sure my final answer is simplified. I'm not allowed to have anything higher than just plain I. If it's an I squared, I need to simplify that using the definition and say I squared is -1. Okay, so I have a couple quick examples here. If it's the square root of -16 times the square root of -25, I'm going to change those to the I form. When I multiply, I get a 20i squared, but wait, remember, I squared is -1, so I actually have a final answer of -20. Here's a little more complex problem. 7 minus the square root of a -36. Again, change that square root thing to I form, minus 6i. 2 plus square root of -9, change it to I form, plus 3i. It's more complex here. I'm going to do the normal foiling. So distribute the 7 to both parts, distribute the -6i to both parts. And then I see I have some like terms in the middle that I can combine. I also notice here when I took that -6i times 3i, I ended up with an I squared. So I simplify that to a -1, which is how I got a plus 18. So I have one more step to combine some more like terms. I have a couple more examples here, but I think you kind of get the idea. You're basically just foiling like you normally would after it's in I form and remembering to simplify those I squareds. Division is the trickiest part of all of this. And before we can do the division, I need to talk about something called the conjugate. A conjugate of a complex number means basically you change the sign of the I term. That's it. Don't overthink it. So if it says 3 plus 4i, the conjugate is going to be 3 minus the 4i. If it's 7 minus I, then my conjugate is going to be 7 plus I. If I'm only given the I part, then I still change the sign. So the conjugate of a 2i is a negative 2i. Now you might be wondering, why do I even care? Well, something really interesting happens when we multiply a complex number times its conjugate. So let's look at the general form. A plus bi times a minus bi. So two general complex numbers that are conjugates because the sign of the I part is opposite. When you FOIL that out, you recognize that the middle terms are going to cancel. And then at the end here, we have an I squared that can be simplified. So it becomes not negative b squared I squared, but actually plus b squared. If we recall that a and b were originally real numbers, and we're squaring them and we're adding them, that means this thing right here is going to simplify down to not just a real number as I have written on the slide, but a positive real number. So it's going to be a way for me to clean up the appearance of my problem. Let me show you what I mean. In this problem, I have 2 minus 5i divided by a 1 minus 6i. You're saying that that's a fraction. Fractions are just another way to write a division problem. So it really is 2 minus the 5i complex number divided by complex number 1 minus 6i. The way we're going to tackle it is we're going to focus on the denominator and say, let's multiply the top and the bottom by the conjugate of that denominator. So you see over here, I have this 1 plus 6i over 1 plus 6i. Well, that reduces to a 1. So it changes the appearance of what I'm dealing with without changing its value. So as I said, we are choosing that conjugate down there so that when I multiply things out, we're going to end up with a very nice real number as a denominator. Okay, so the outer and inner cancel, we simplify the I squared, combine, and we got our 37. On the top, you do normal FOILing, combining all your like terms, again, simplifying the I squared, and we come down to this right here, this kind of complex fraction. That's fine, but if I started with something that had a singular real part and a singular I part, I'd like to end with something that looks like that. So most of the time, you're going to see our homework or a textbook asking for a nicer form, a plus bi form. That just means I separate out. So 32 over 37, real part, plus 7 over 37, I, the imaginary part. I think you won't find this section too difficult, but if you have questions, as always, just let me know.